Today on Math with Malia, we're going to cover Eureka Squared, Math 7-8, Module 5, Lesson 20, the volume of spheres. In previous lessons, we have calculated the volume of three-dimensional prisms and unique three-dimensional shapes like cylinders and cones, and we compared the volume of cones and cylinders and pyramids and right prisms. And we saw that if we had a three-dimensional shape that had an apex, as in with a pyramid or a cone, then that would be 1/3 the volume of the right prism or cylinder. So then we would have to multiply the formula for volume, area of the base times height, by 1/3. Today we're going to develop the formula for volume of spheres using a similar strategy. Okay, so you can see we're going to use our visual for volume, again comparing a sphere to a cylinder. They have the same diameter, that means they have the same radius and the same height. Here's the volume of the cylinder. And they're going to displace the water from the cylinder by submerging the sphere. So how much volume gets displaced from the sphere? When it is fully submerged, how much water gets displaced or pushed out? So now we have the volume of the water that is left over after we submerge the sphere. And the cone has the same diameter again, so it will have the same radius and height as the cylinder and the sphere. And we're going to see how much volume was left inside the cylinder. Looks like it's enough to fill up one cone. And if you remember the relationship between a cone and a cylinder, the cone is 1/3 the volume of the cylinder. So the sphere displaced 2/3 and the cone had left. Okay, as we saw in those videos, the sphere displaced 2/3 of the volume of the cylinder. And what was left in the cylinder filled up one cone, or 1/3 of the volume of the cylinder. So if we have three solids that all have the same radius, the sphere, the cone, and the cylinder, and the diameter of the sphere is the same as the height of the cone, so that means it would go all the way from the top of the apex to the center of the base. What is the relationship between the volume of the cone and the volume of the cylinder? Well, in the video we saw that the cone took up 1/3 the volume of the cylinder. So we could say the volume of the cone was equal to 1/3 times the volume of the cylinder. And we learned this in lesson 19 also with the videos that showed displacing the water with the cone. What is the relationship between the volume of the sphere and the volume of the cylinder? So as we saw in the video just now, the sphere displaced 2/3 of the volume of the cylinder. So we could say that the volume of the sphere is equal to 2/3 times the volume of the cylinder. Okay, and what was left of the water inside the cylinder filled up the cone, or that last 1/3 filled up the volume of the cone. What is the relationship between the volume of the cone and the volume of the sphere? Well, since the cone had a volume of 1/3 the volume of the cylinder, and the sphere had a volume of 2/3 the volume of this cylinder, well then the volume of the cone is 1/2 the volume of the sphere, because 1/3 is 1/2 of 2/3. Part B, what is the relationship between the volumes of the cone and the sphere and the volume of the cylinder? So how my class liked to say it was that the volume of the cylinder, the whole shape, was equal to the volume of one cone plus the volume of one sphere, where 2/3 of the volume of the cylinder was in the sphere and 1/3 the volume of the cylinder was in the cone. So if we added up one cone and one sphere, we would get the whole volume of the cylinder. Okay, so here's our formula. The volume of the sphere is 2/3 times the volume of the cylinder. So let's think, how can we replace the volume of the cylinder? Do we know the formula for the volume of the cylinder, what's inside the parentheses? Well, yes, we do. We've developed this formula before, so let's rewrite this formula, substituting the volume of the cylinder formula into the parentheses. So we know that the volume of the cylinder is the area of the base times the height, and the volume So we know that the volume of a cylinder is the area of the base times the height, and the base of the cylinder is a circle. So then what is the area of a circle? Well, the area of a circle is pi times r squared, we know this, times height. So the volume of the cylinder we can replace inside the parentheses would be pi times r squared times the height. Okay? Well, let's think. What is the height of a sphere equal to? The height of the sphere goes all the way across from the top of the sphere to the bottom of the sphere. So the height of the sphere would really be equal to the diameter. And so the height of the sphere would be equal to 2 times the radius. So we can rewrite this formula again by substituting 2r for height. So we're going to rewrite the formula again. Since I'm multiplying, I'm not going to have the parentheses anymore. Just wanted to show you what I was substituting for volume of the cylinder. 2/3 pi r squared times, I'll put this in parentheses, 2r. So we're substituting height now for 2r. That's what we're substituting. Okay, now we can do some math and distribute that 2r. We can do some multiplication and simplify our formula even more. So let's see what we get. Volume of the sphere. 2/3 times 2 would be 4/3 times pi. And I have r squared times r, and I know my exponent rules. If I multiply with the same base, that means I add the exponents together. So I have r squared times r would give me r cubed. Here is the final formula for volume of a sphere. Okay, 4/3 times pi times r cubed. And that's the formula we're going to be using in this lesson to calculate the volume of spheres. So we've completed number 2. We know the volume of the sphere is equal to 4/3 pi times r cubed. So here in this video, you can see that the radius goes to all points on the sphere. Every point on the sphere is equidistant from the center of the sphere. So that's why we use the radius in calculations of volume, because the radius is taking up all of the space inside of the sphere. Okay, number 3, let's do some calculations. Find the volume of a sphere with a radius of 2. So let's make sure we're doing our good mathematician rules, and we're going to write what we know. So we know the radius is 2, so r equals 2. And then we're going to write the formula we're going to use. Volume of a sphere equals 4/3 times pi times r cubed. And then we can substitute what we know into our equation. And I'm going to rewrite everything, and all I'm going to substitute is r. So instead of r, I'm going to write 2 cubed. And then I can simplify my equation some more. Volume equals 4/3 times pi. 2 cubed is 8. And one more time to multiply 4/3 times 8 would give me 32 thirds times pi. I'm going to leave my answer in pi notation so I have the most accurate answer. I'm not going to multiply by 3.14 and get an estimate unless they ask me to. Okay, let's look at number 4. A sphere has a diameter of 12 units. So now they're giving us the diameter. We know the diameter is 12. Can we figure out the radius? Well, yes, we know the radius is just half of the diameter. We're going to find the approximate volume by multiplying by 3.14. So we will multiply by pi and give an approximate answer for this question. Let's write the formula. Always write the formula before you start calculating. 4/3 times pi times r cubed. Substitute what we know into the equation. So instead of r, I'm going to substitute 6 cubed. And then we can do our calculations. Volume equals 4/3 times pi. 6 cubed is 216. And then if we multiply 4 times 216 and then divide by 3, then we're going to multiply that answer by 3.14. So as we do that calculation, I'm going to get an approximate answer, so I will use my squiggly equal sign. And we should get 904.32 as our approximate. After we do this calculation here, 4/3 times 3.14 times 216, our approximate answer would be 904.32. Okay, let's take a look at number 5. A standard American billiard ball has a diameter of 2 1/4 inches. Let's write what we know. I know the diameter is 2 1/4. That means the radius is half of that, or 1 1/8. Find the approximate volume. So again, we're going to multiply by 3.14 to get an approximate answer. Let's write the formula for volume of a sphere. Volume equals 4/3 times pi times radius cubed. Substitute what we know into the equation. So I put the r in parentheses so we know to put the 1 1/8 in parentheses. And everything is cubed. And since we're multiplying by 3.14, we can change pi to times 3.14 in our equation. And doing that calculation using our scientific calculators, our approximate volume, 5.961. If we go 3 decimals, the decimal keeps going, but we can round it to the thousandths. Oh, it does say round to the hundredths. So if we round to the hundredths, then we would say 5.96. Okay, that was not good. Let's do this one again. Okay, let's take a look at number 5. A standard American billiard ball has a diameter of 2 1/4 inches. Let's write what we know. The diameter is 2 1/4. That means the radius is half of that, or 1 1/8. Find the approximate volume by multiplying by 3.14. And it says to round to the nearest hundredth, so we're going to want 2 decimal places. Let's start with writing the formula for volume of a sphere. Volume equals 4/3 pi times r cubed. Volume equals, I'm going to substitute what I know. And since I'm going to use 3.14 for pi, I'm going to substitute that in right now. And instead of r, I'm going to write 1 1/8 cubed. Doing my calculations, this will give me a very long decimal, but an approximate answer to the hundredth would give us 5.96 cubic inches for the volume of our billiard ball. Okay, number 6. A cylinder has a diameter of 16 inches. Okay, we know the diameter is 16, and it has a height of 14. Okay, so be careful here. We might automatically think, well, the diameter is 16, so the radius should be 8, right? But this says, what is the volume of the largest sphere that will fit inside this? So if the diameter were 8, would it fit in the sphere or in the cylinder? would it fit in the height of the cylinder? What's halfway through the height of the cylinder? That radius would have to be 7. So it can't have a radius of 8, otherwise it would be sticking out the top of our cylinder. So the radius that will fit inside the cylinder is going to be 7. Okay, so we had to think carefully about this one. Now that we know the radius, we can plug that into our formula for volume. Volume equals 4/3 pi r cubed. Substitute what we know. And it didn't ask for an approximation, so I'm going to leave my answer in pi notation. Times 7 cubed. The volume would then be, 7 cubed times 4 divided by 3. We're going to leave it as a fraction, 1,372 over 3 times pi. There's the actual exact volume of the sphere that will fit inside that cylinder with a height of 14 inches. We should label this with our inches, cubic inches. Okay, so how are you doing with using the formula for volume? Make sure you're writing the formula for volume every time. Write down what you know from the problem, and then substitute that into the equation for careful and accurate calculations. The next section you can work on your own. It's going to give you this picture, and you're trying to find out strategies to figure out the volume of the sphere. Yes, it's a two-dimensional representation, but can you approximate or figure out how to calculate the radius so you could use your volume for spheres to calculate based off of the radius? Okay, so think about what you can do. Some students maybe used a ruler or something straight that they could measure. Okay, so to debrief, one of the relationships that we determined today was that the volume of a sphere is 2/3 the volume of a cylinder. Remember the video. The sphere displaced 2/3 of the water from the cylinder. Do you think this will be true for every sphere and cylinder pair? Well, what were the requirements in the video? They had to have the same diameter. Okay? So the radius of the sphere and the cylinder is important for them to have this relationship. What formula did we develop to find the volume of the sphere? Well, you can look back early in the video how we figured it out. But the volume of a sphere is equal to 4/3 times pi times radius cubed. After we simplified the 2/3 times the volume of a cylinder, which was pi r squared times the height. The formula for the volumes of cones and spheres are related to the formula for the volume of a cylinder, as in the previous lesson. That's why we were multiplying by 1/3. Okay, so if you can't remember all of the formulas, just remember the basic formula for volume. Volume is the area of the base times the height. Okay, this is for a right prism. So if it is a right prism, if there is no apex, you can figure out the volume. Whether the base is a triangle or a rectangle or a pentagon or a circle, you can find the volume of the right prism. And then we just need to remember that if there is an apex, as in a pyramid or a cone, then we had to change the formula for the volume. It was not the whole cylinder, it was 1/3 the volume of whatever that prism was. Okay, so then that's how we multiplied by 1/3 to figure out if it was a pyramid or a cone. And likewise, if it is a sphere, we know that it displaced 2/3 the volume of the regular cylinder, the right cylinder. And so that's how we get to this formula, 4/3 pi r cubed. Okay, and if you forgot how we got to that formula, go back to the beginning of this video when we worked out simplifying the formula for volume of a sphere compared to volume of a cylinder. All right, great job today, guys. Make sure to check back for other videos to help with your math.